I know if I gave you this graph here, x squared minus 4 over x minus 2, you can't help but see the difference of squares. And I know you do. So then you cancel. So what that gives me is the graph of y equal x plus 2. And you know that graph of y equal x plus 2 is just a line with y-intercept 2, right? That's what that 2 is. Okay, now here comes the complicated part. Because I cancel these two, this, I know that there's a hole where x minus 2 equals 0. So when x equals 2, not this y equals 2, but when x equals 2. So when x equals 2, I put a hole in the graph. What is that y value? So if I put x equals 2 back into the original equation here of this line, don't you know that that's 4? I do. Okay, so this is the graph of this, and then let's look and see what this is saying. When x is 2, make y equal to 4. Oh, well, you look at that. It just fills it in, so it's a nice line. Let's try another one. Okay, so let's see this one here. So this would give me y equal x minus 3, x plus 3 over x minus 3. I cancel, so I get y equal x plus 3. That's the y-intercept, right? So just make sure we keep them separate. That's the y-intercept. And let's talk about where the hole is. So the hole is where x minus 3 equals 0, because those are the terms we canceled, right? So that means the hole is at x equals 3. Make sure we don't get that mixed up. So that's x equals 3. So that's where the hole is. Where's that y value? I put 3 into here, and that's where I get 6. Okay, so that's the first part of the graph. And then this part says here, when x equals 3, let the y equal 0. There it is. So that would be the graph, and it does pass the vertical line test, right? Good. Okay, so we're going to be dealing a lot with exponents and simplifying, so let's talk about these. So first off, I would rewrite anytime you have a negative exponent and put it in the denominator. So that's a 1 over y minus a 1 over x all over x minus y. Okay, so it's a big complex fraction. And then what we want to do to eliminate these is we want to multiply the numerator and denominator by the least common denominator. So if you were asked, just on the side here, to join those together, you know the least common denominator would be x times y. That's what I'm going to do. So I'm going to multiply numerator and denominator by xy. And I'm going to be careful to distribute. So let's go through here. And I want to cancel as I go to save myself some time. So if I take this 1 over y times this, that gives me x. And then if I take this 1 over x times xy, that gives me y. And I know I have a subtraction in between. Almost never do you multiply the denominator out. So let's just leave it. And will you look at that? Can you see that these two terms cancel? So I'm just left with 1 over x minus y. Okay, so what about this one? If I was to add those two fractions together, I hope you can see that the least common denominator would be x times x plus h. X times x plus h. Remember, this is not an equation, so you have to multiply numerator and denominator by the same thing so that you don't change your bank account balance, right? You have 100 over $1. You can't just multiply the numerator by 2, right? You have to do 2 over 2. Just making sure you, I wrote 100 over 1. You have to multiply 2 over 2 so you don't change the value. So that's what I'm doing here. So let's make sure we're being careful. I'm going to put parentheses, and I'm going to say, okay, what happens when I multiply this term times this? I want you to cancel as you go. So 1 over x plus h times this. You can see the x plus h's cancel, so you get x. And then, different color here. So then if I multiply negative 1 over x times this, You see the x's cancel, so I get x plus h, but be careful, whoops, be careful, you've got this negative sign there, oops, oh gosh, get rid of that, go away, okay. So I have to make sure I carry that negative sign, and you know you have to put parentheses. In the denominator, what am I left with? Almost never multiply the denominator out. Okay, so let's look at the numerator. I'd have x minus h all over hx, x plus h. Those x's go away. So I'm left with this. Oops, dropped an h. Then I can see, oh, look at that. The h's go away. And so on the numerator, you know I'm left with a negative 1, x plus h. So we're going to be seeing things like this in days to come. All right, so let's look at this one. So this, again, I would recommend you rewrite the fractions, or the negative exponents as the fractions that they are. Okay, so let's think about this. Some people get kind of confused. If I was to try to add or subtract, doesn't matter, those together, can you see that I just need to multiply this one by x over x, and then they have the same denominator of x squared? So the same denominator in this case is x squared. So I'm going to multiply numerator and denominator by x squared. Okay, so then distributing, so I'm going to take x squared times 1 over x squared. Oh my goodness, that's just 1. And then x squared times 1 over x, that's a minus an x. And then I'm going to multiply these, and you know you add the exponents. So that's it, x to the 5th. All right, let's just finish this one last one here. So I can see that these two denominators are going to be needed to be multiplied together. So I'm going to need to multiply by x plus 1 times x minus 1. It is difference of squares, but I'm going to leave it like this because it's going to be easier to cancel. All right, so let's make sure we're thinking about this correctly. So if I multiply this term times all of that, cancel as you go, the x plus 1's go away, so I'm left with an x minus a 1. And then let's think again. If I multiply this term times all of that, the x minus 1's go away, so I'm left with a minus an x times an x plus a 1. So it's really important to keep those parentheses. So let's look at what's happening in the denominator. I have this and this and this. Hey, all right, these are the same. So I can say x plus 1 squared times x minus 1. So let's multiply the numerator out, see if there's anything I can do. Minus x squared minus x over x plus 1 squared, x minus 1. Oh, will you look at that? I can see the two x's go away, right? So I get a minus 1 minus x squared over x plus 1 squared, x minus 1. And that's it.